Hi, welcome to the shop here at Badass Racing Engines. This is where we build the engines for some of the nastiest cars on the street and some of the fastest cars at the track. This whole segment's on performance carburetors. We're going to be talking about all kinds of different models of carburetors for performance street use and for track use. We're not going to be covering the kind of carburetors and models that you'd find on Grandma's grocery getter. So let's start with this one right here. This is a very common carburetor that you find on mild performance motors. This one's by our friends at Edelbrock Corporation. It's an AFB design, and what AFB means is aluminum 4-barrel. These were pretty popular on cars of the 60s and early 70s for performance reasons on the performance models of cars. They're still popular today for mild performance, nothing too racy. You're not going to see them on pro stockers or super gassers or super comp cars or anything like that, but you'll find them on milder street cars. Anything from stock motors to maybe 400 horsepower motors, stuff like that. And beyond that, we go to different types of carburetors. But let's look at the different features of this particular carburetor here. The model numbers on the carburetors are right here in the corners on these particular ones. They designate the size, which would be the CFM rating of the carburetor. This one right here happens to be a 600 CFM. That means it's capable of flowing 600 cubic feet a minute of air. It's a pretty standard size for your basic 300 cubic inch to 350 cubic inch motor. For semi-performance, maybe a little economy. Nothing too radical though. Let's look at the different features. We have the electric choke here. A lot of street motors use electric chokes. When you get into the really serious performance engines and stuff, we don't use chokes at all. We'll get into that when we get into other carburetors here. Let's look at some of the features on the front right here. We've got a very large vacuum port right here. This usually runs for the PCV system, which is the positive crankcase ventilation system. And it's PCV, not PVC. A lot of people say PVC. It drives us nuts. It's PCV, positive crankcase ventilation. This is manifold vacuum signal that goes into the valve cover to evacuate any air pressures or anything like that out of the crankcase, which can actually rob you of horsepower. Engines kind of make air, they pump air inside, and the more air pressure you have inside, the less horsepower you make. So we want to evacuate the system, and that's what this hookup is for right here. This can also be used, a large port like this, or one in the back. We do have one in the back side right here where a fitting would go. This is also manifold vacuum. What this port could be for, this could also be for PCV. It could also be used for like power brake booster or anything like that where you need a really good manifold vacuum signal to run a vacuum accessory like that. So go back to the front right here. Usually on most carburetors you have two small vacuum ports on the front. There's usually an upper one and a lower one. And what the upper one is, you can see it's a little bit higher than the lower one right here. And what that is this is above the throttle plate. This is the throttle plate line right through here that the butterfly is attached to. That's this right here. If we look inside here, right back in here, this particular vacuum port right here takes its vacuum signal right at about the level of the throttle plate. This one right here, the upper ones, they're usually designed for your vacuum advances and things like that. They're what we call a ported vacuum port on here, simply to run like a vacuum advance on a distributor, which is basically for part throttle economy. Real hardcore motors don't even use vacuum advances. The next one we have right down here, this is manifold vacuum. You can tell manifold vacuum when you put your finger over it. It'll suck your finger right on it tight with full manifold vacuum. The same amount of vacuum in this port right here would be right here. What that would be for is running the modulator valve on your automatic transmissions to give it a vacuum signal to help it upshift and know when to have the shift points. Then the other features that most carburetors have, these right here are your air-fuel mixtures, the air-fuel mixture screws. And what these do, this controls this side of the carburetor, this controls this side. And there's a lot of misconceptions about air-fuel mixtures, which we'll get into a little bit later on the tuning of carburetors and how to adjust them and set them. But basically, each screw right here controls both fuel and air for the idle circuit only. It only controls at an idle. Once you kick the throttle open, these no longer work. And we'll get into that a little bit later, but basically these help control the amount of fuel and air feeding the motor at an idle. And that's why we call them idle fuel mixtures or air fuel mixtures on the screws. Look at some other features here. Of course, we have the linkage right here. This is what attaches to your throttle pedal or your throttle linkage. And that actuates the butterflies. Some people call them butterflies. We call them throttle plates. To each his own. It's 6 to 1, half dozen the other. But on this side right here, these are the primaries, and these are the secondaries. So this is the front of the carburetor right here. So when you're driving around town, you're mostly on the primaries. That's your up to half throttle driving. When you really kick it in and you put your foot in it, the secondaries will open up and help dump more fuel. That's because this is a 4-barrel carburetor. What that means is there's 4 barrels, 1, 2, 3, 4. And this is the only one we're going to find here in this series. That's what we call a spread bore. And this isn't much of a spread bore, but it is a spread bore type carburetor. And what spread bore means are the primaries are a little bit smaller than the secondaries. You can notice here the diameter of these butterflies right here, these throttle plates, are one size. Secondaries are quite a bit larger. Now on grocery getter style cars, particular cars that run like a quadrajet carburetor or anything like that, they've got really small primaries for driving around town for better fuel economy, and very large secondaries. So when you stick your foot in it, it really dumps the fuel and gives you the performance you need when your foot's in it. But you don't get that around town for economy reasons. This is a little bit different than that. There's not quite as much difference between the primaries and secondaries. Where on all the other performance carburetors that we're going to be talking about, they're what we call a square bore, and they're all equal in size. But this is the only one we're going to be seeing in this series that's on spread bores. So let's look at a few more things right here. This right here is the idle adjusting screw. And all that does is when you screw it in, it pushes the linkage back a little bit, or you can screw it back out and it brings the linkage back. And all that does is control the butterflies right here. Just slightly opens them, slightly closes them, just to control the idle speed of the motor. And that's going to be different for different size motors. I mean, if this is on a 300 cubic inch motor, it's drawing 300 cubic inches of air in, it might need to be set quite low. If it's going to be feeding a 454 cubic inch motor or something like that, you might want to kick it open a little more because it's going to need a little more fuel and air to feed that motor. That's a lot of cubic inches. So let's look at some other little goodies right here. On top we have the choke plate. Again, that's activated by, this is an electric choke right here. We've got the terminals right here for it that you send a 12-volt power source to it, and there's a little coil spring inside here. As it gets hot, it pulls the choke open and allows more air inside there. Let me kind of explain how a choke works, because most of the carburetors that we're going to be dealing with after this carburetor right here won't have chokes. Basically what a choke does when you get in the morning and you get in your vehicle, when you pump the throttle once, this closes. And basically what it does, this is where all the air is coming through, closes it off. So what's going to happen is pretty much a lot of fuel is going to be going through. The whole idea of a carburetor is just to meter fuel and air. And on basic, I mean like an economy carburetor, you're going to want 14 and a half to 1, somewhere right in their air-fuel ratio. So it takes 14 to 14 and a half parts of air per part of fuel to supply an economy style motor for optimum economy. So what's going to happen when it's cold, when an engine's cold, it's running very inefficient. So what we're going to need to do is when it's cold is shut the air off to let a lot more fuel down there. It increases the vacuum signal, it pulls more fuel through the carburetor, and by basically cutting the air supply off, it dumps more fuel also. And as the engine warms up and it's running more efficient, you need less fuel and air. And that's what happens as the electric choke here starts opening up. It starts opening this plate right here, and it starts readjusting the air-fuel mixture that's going through the carburetor there. It starts allowing more air, so it kind of leans it out, and a more efficient motor needs less fuel when it's warmed up. So we'll start looking at other little goodies right here. On the linkage, here's where we talked about before, it hooks to the gas pedal. So when you push the gas pedal, it pulls it back. Then we have the secondary linkage. This linkage right here activates the secondary butterflies back here, or throttle plates. And that's really, on one of these carburetors right here, that's about it. I mean, there's not much more to these little guys. This is an excellent carburetor. If you're not real sure which one to pick, you could call the tech line at Edelbrock. They'll help you pick the right one out. They got a great staff down there. This is really good for just your basic drivers. That's not too radical. Maybe a little strip time here and there on Wednesday night drags or something like that. But when you're really going to get into the hardcore stuff, we'll start talking about these other big boys over here. Okay, let's talk about the second type of performance carburetor right here for mild motors. This one right here is a Holley carburetor. It's a 600 CFM. It's a very popular model. It's what they call a 4160 model. It's got side-hung floats, and this is a 600 CFM vacuum secondary carburetor. We'll get into all that in a little bit here. This particular model right here is an 1850. What that means is on the choke horn right here, we can look right here. There should be a set of numbers right there, and that should say 0-1850. Sometimes there's a -1 after it, or -2 or -3. That simply designates what type of linkages and things like that it has. but the basic model is an 1850 carburetor. It's kind of their universal medium to light performance carburetor. This right here is a single gas line inlet right here. It's side hung floats, which means the floats are actually pivoting off to the side right over here. Okay. On the 4150 model carburetors, which we'll get into in a minute, they're a center hung float, which means the floats pivot up and down in line, straight forward and back. But this is a side hung float. These are very popular carburetors. They came on quite a few vehicles back in the 60s and some of the 70s and stuff, but different various additions and subtractions on these, meaning they might have extra vacuum ports for smog devices, or they might not have different vacuum ports on them and stuff for some of the subtractions that they might have taken off this particular model. But this is a universal model. It's good for your basic 300 cubic inch, maybe to 350 cubic inch motor for just some mild performance, 300, 350 horsepower or something like that. Of course, you could probably go a little more or a little less, but that's a good choice, for that type of a vehicle. Let's go over the basics of this carburetor here and the little features it has. This is a manual choke carburetor, so the choke actuator is right here. It goes to a choke cable. That's the least expensive way to purchase a carburetor is with a manual choke. But this is what activates the choke, and just like we talked about on the first one, the first carburetor we covered on AFBs, that when you close the choke off, all the air is coming through here. When you close it off, there's not much air getting in there. Okay, so if we open it, that lets more air in. When an engine's cold, we'll talk about that one more time, when the engine's cold, it's less efficient. It needs a lot more fuel to sustain it to run. So when you close it off in the morning, it basically shuts most of the air supply off, so nothing but fuel can get in there. And as it warms up, you have to choke it back up, or open the choke back up. But that's the way chokes work. They're fairly simple. Let's go on to here. We talked about the float bowls. These are the float bowls right here, and they need to be adjusted. And later on in this segment, we'll talk about adjusting when we get to that portion of it. But right on the side of the carburetor right here, we have these little sight plugs, and these are what gets removed to find the final adjustment for the float level, because that's the actual where the fuel is inside here. There's one in the front, and there's one in the back side right here. This is a 4-barrel carburetor. It's a what they call a square bore. If we flip it up, we can look at all the throttle plates. They're all evenly spaced and evenly sized. No difference in them. That's a square bore carburetor. Of course, this is a vacuum secondary carburetor, so when we open up the throttle plates, only the primary is open. The secondaries are vacuum actuated. Now, how they work, it's actually really a simple way they work. There's a vacuum pot over on the side right here. What's inside here is a little diaphragm, a rubber diaphragm, and of course it has linkage coming out of it. This linkage right here is actually attached to the diaphragm. That's part of the diaphragm. So what happens is, let me explain how this works. Inside the carburetor right here, I believe we have one right here. If we can see, I don't know if we can get an angle inside here. There's a hole right inside, right here. I don't know if you can see that in there. We possibly might be able to. This is the body of it's a modified body of a vacuum secondary type carburetor. And what that hole is right there, as air passes through these venturis, this is the primary side. Of course, the choke horn's been milled off, but the primary side, air is passing through here. And just like a siphon, what happens is, as the airspeed increases, it starts siphoning air out this hole. And when it siphons air out, it starts drawing it out of this vacuum diaphragm here. And what that does is, when you're on the throttle and you open it up, and as the airspeed increases through the primary side, it starts pulling on that secondary diaphragm and opening the secondaries. And it'll open, open, open. The really cool thing about these on vacuum secondary carburetors, they're awesome for the street. A lot of people make the mistake of getting double pumpers for the streets. We'll go into what a double pumper is in a few minutes, but just for a really quick, a double pumper, when you actuate the throttle linkage and you do this, at half throttle, the secondaries start opening. They're mechanical. Sometimes they call them a mechanical secondary carb. That's not an ideal carburetor for especially heavy vehicles or anything like that on the street, unless you've got some really low gears in the back, in the rear end, or you have a very high stall converter, or it's a very light car, or it's a very radical motor that's running at high RPMs all the time. These carburetors are not designed for that type of use. These are designed for basic driving and basic performance. But the neat thing about a vacuum secondary is you can be dead on the line, just at an idle, stab the throttle wide open, and only the primary is open. And we have to keep in mind what's happening with the motor. All the motor really is a giant vacuum pump. You've got 8 pistons in there going up and down. There's drawing fuel and air inside the motor. Well, what's happening with a carburetor is when you open up the plates, and you have the plates closed and you open them, the vacuum that everything's drawing in goes away. I don't know if you've ever seen a vacuum gauge on a motor. When you have a vacuum gauge hooked up, when you're at an idle, a stock motor might have 18 to 20 inches of idle vacuum. A race motor might have 4 inches because the radical camshaft and the overlap of the cam, it doesn't have much of an idle signal. Well, when you open up throttle plates, you lose the vacuum signal. If you watch a vacuum gauge, it'll actually go down to 0. Engines don't really run too well with 0 vacuum. I mean, with no vacuum, there's nothing going in the motor. So a vacuum through a carburetor is pretty important. What we need to do, though, is understand that with the motor being a vacuum pump and the throttle plates creating or allowing the vacuum to happen, just think of it like this. Think of a shop vac. You know, when you turn your shop vac on and you have the vacuum hose and you're vacuuming up the floor or anything like that, when you put an attachment on it, most attachments neck down to a smaller inlet size. And boy, you put your finger over that, man, you can really feel the suction. But you take that off and you put parts of your hand over it, you don't really feel much suction. That's because you need to neck it down, and the only way you can create vacuum is to plug off the end, and the vacuum inside the hose will increase. Well, it's the same thing with a carburetor. It's real similar to that. With the motor being the vacuum pump and the throttle plates being closed, the area underneath the carburetor, between the carburetor and the inside of the motor, that is a high vacuum signal. When we open it up, not much vacuum. The difference with one of these, though, being that vacuum feeds a motor, when you open this up off the line, motor takes right off because you haven't opened up all 4 barrels. So what happens is the airspeed, the velocity feeding the motor is awesome with one of these things. It keeps the speed up. Well, the faster the speed going in the motor, the faster the motor is going to wind up and rev. That's a good way to, I mean, that's great for a street motor. On mechanical secondaries, though, when you open all 4, the vacuum drops even lower than you would normally want it. That's when you have guys with cars that dog off the line, or they say, man, I got to feather the throttle or something like that. Put it this way. If you have a car and you floor it off the line and you have to feather the throttle, your carburetor's wrong, okay? There's something wrong. You should be able to be from a dead stop, stab the throttle right to the floor, and the car should just take off, okay? It should go like a bat out of hell. If you have to feather the throttle, something's not right. Cars aren't designed to have throttles being feathered all the time. And put it this way, while you're in your car feathering the throttle and screwing around trying to get it to go and not get it to bog off the line, the guy with one that's tuned well, he's already a car length or 2 in front of you. He's gone. He's got it to the floor, and he's not concerned about feathering. He's concerned about going to the next gear, and he's blowing your doors off. So if you have a problem with the carburetor like that, find someone that can help you get another one or get it tuned properly or get the correct one to remedy that problem. So let's look at a couple other things on this carburetor. Let's just kind of go around a line here. This is a single pumper carburetor. And what that means, what we're talking about pumpers, this is the accelerator pump. Okay, and what the accelerator pump does, when you give it the throttle, you can actually see it push down. There's a diaphragm in there that squirts fuel in the motor. And there's little nozzles inside here, and actually here's one right here. Little nozzle right here, little streams of fuel, little jet streams of fuel come out of there. When you give it the throttle, it'll spray fuel. Okay, these are called squirters. All right, well, the accelerator pump, when you give it the gas, squirts a little fuel in there to help the engine, when it gets off its idle circuit, go in the transition of the accelerator pump, which gives it off-idle response. You probably heard cars where, you know, they're sitting there idling and you give it the gas and it goes, whoom, whoom, there's nothing there. What that is the accelerator pump's not working or it's not adjusted correctly. When they're not working, what happens is you're driving down the road and you give it the throttle, it has a really bad hesitation off the line. You give it the throttle, it goes, and then goes. That means you're not getting enough squirt of that fuel. Because what happens, you've probably heard of main jets. We're going to get into those a little bit later, but let me try and explain this real quick here. There's different circuits in a carburetor. There's an idle circuit. That's what controls the amount of air and fuel feeding the motor at an idle. Then we go into a transition mode, which is the accelerator pump. As we give it the gas, this manually squirts fuel into the engine. Because when you open the throttle plates on the bottom here, all of a sudden air goes in. Well, you need to meet that air with fuel. And all the carburetor does is regulate or meter fuel and air. And a performance engine needs, a 13 and a half to 1, somewhere's right in there, air-fuel mixture ratio, okay? So that's what these are designed to do, is just meter the fuel and air. Well, different transitions, different loads of the motors at different times meter air and fuel differently. So we have to have different parts of the carburetors doing different things at different times to keep that at a constant. and change under loads when you're under a loaded condition, like pulling a long hill or hard on a throttle, or if you're just putting down the freeway at 55, 60 miles an hour and you're just barely giving it throttle, then there's different transitions. But the first circuit in this is the idle circuit. Second one's the transition where we activate the accelerator pump. And when we open the throttle plates, that squirts through the squirters. It's hard to see them in here, but that squirts right through the squirters right here. Squirts fuel in. That meets fuel with the air that just came in. Then about a second and a half later, we start drawing off the main jets. And what that does, the main jets draw out of here, right here. These are called the boosters. This carburetor has them too. There's 4 of them in there. There's one in each throat, right here. And these are boosters. Each one of these is activated by the main jets inside. So as vacuum gets drawn through the carburetor, it actually sucks air through here, which draws up fuel, and it mixes it inside, fuel and air, and that's what feeds the car and keeps the car going down the road. We can control that by jet sizes, whether they're larger jets for more fuel or smaller jets for less fuel, but that's what activates this system right here with the boosters. And that's just going down the road. When you're also going down the road and you're just cruising and the carburetor has, say you're at quarter throttle or something like that, and you want to give it a little bit more to accelerate, maybe say you're going 60 and you want to accelerate to 70 just to get around somebody. Well, that right there, when you give it a little more throttle, you've opened up the plates more, it'll actually lean out for a second. That's when this pump comes back in. It takes that little lean area out again, gives it more fuel. If it's not working, that's when you're cruising down the road and you get that hesitation. You're driving, give it a little gas, goes, and then goes. That area of hesitation, that's how long it takes for the main jet circuit to start to pull through and start working. And that's a lag time in there. Well, the accelerator pump takes away that lag time. So if it's not working properly, it's a pretty telltale sign that you get that hesitation. Let's look at some other little things right here. This is the linkage that controls the primaries. This is the linkage that controls the secondaries. And you notice you cannot open the secondaries when the carburetor, when it's closed. They can barely move because as the linkage goes back, now it can activate. Now, let me tell you something about this. Some idiots out there think that you can take a screw and a nut and put it in here and make this thing a mechanical secondary. Don't do that. That is so lame. That is not what that's not what this carburetor is designed to do. And if it was as simple as doing something like that, don't you think the engineers at Holley and all the other carburetor companies would have thought about that? It's not their first day building carburetors, okay? So don't think that that's going to fix some sort of a problem or make your carburetor a performance carburetor because you stuck a bolt through here and opened up the secondaries mechanically. All you're doing is leaning out the motor, okay? What's going to happen is you're going to open it, it pulls those secondaries open. What's back here? No accelerator pump. So when we don't have an accelerator pump back here, you get an extreme lean condition all of a sudden, the motor leans out and it doesn't run very good. That's just not the way these carburetors are designed. If you want a mechanical secondary carburetor, get a mechanical secondary carburetor. All right, let's look at the other features of this carburetor here. On the side right here, we have the idle adjustment screw, just like all the carburetors have. And again, that just, if you screw it down in, it pulls the throttle linkage back a little bit, ups the idle. If you screw it back out, it'll drop the idle down. All carburetors have that. Go on here to the back side here. The rear float, of course, we talked about this is a vacuum secondary carb. It's a single pumper, which means it only has one accelerator pump on the front. The back bowl does not have one. There's nothing back here. It's just a regular float bowl. We come around to the side. Here's a PCV valve port right here. This would go, like I said before, carburetors have different vacuum ports and different features in different locations. This one happens to have it out the side. It's still a 3/8 port right here, and this would go to like a PCV valve or possibly power brakes or anything like that that needs a good solid manifold vacuum signal. Come around the side over here. Here's the manual choke linkage. We come around here and there's a vacuum port here and then there's one right up underneath here. Now this is above the throttle plates. So above the throttle plates means it's like a siphon style vacuum. What the upper port here is for vacuum advance on the distributors. So you get that part throttle economy. Of course, a lot of really high-end performance motors and stuff don't use vacuum advances, but lesser performance motors and all street motors and stuff would use vacuum advance. But that's what this upper port's for. There is a port down here, hidden under here. Most Holleys have this down here. This is manifold vacuum. This one right here is pretty much used only for automatic transmissions to go down to the modulator valve to help the transmission upshift. This one is almost never used, in fact pretty much never used for vacuum advance. And a lot of people make the mistake of hooking vacuum advance up to here or the transmission up to here and things just don't work right. And again, the way you can tell the different vacuum signals, Manifold vacuum down here, if you put your finger on it when the engine's running, it'll suck your finger right on there, because it's, if you have 16 inches of vacuum in your motor, or 10 inches or 12 inches or whatever the vacuum signal that your motor is pulling, depending on your cam profile, that's how much vacuum is going to suck your finger on there. On the sides right here, you should feel almost nothing. It should be, because it's such a small airspeed at an idle coming through here, it's not enough to draw through here. It's only when the throttle's opened up and the engine's starting to draw a lot of air through there is when this starts to work. So at an idle, if you put your finger on here, probably won't feel anything, or very minimal. So that's an easy way to tell which one to hook into. If there's no vacuum or very little at an idle, that's the vacuum advance. If there's a lot, that's manifold vacuum. Okay? And that's pretty much the features of this little carburetor right here. Again, this is a nice little 600 Holley, great for a mild performance motor, very popular carburetor. And we'll go on to the other series of carburetors next. Okay, we're going to talk about this carburetor here. This is a very popular Holley right here. It's called a 3310, which is a 750 vacuum secondary. Back in the days when this carburetor first came out and got designed, it was actually designed for the SS396 Chevelles. When this carburetor first came out, they used to call it a 780 vacuum secondary. Just recently, a few years back, they decided to call them 750s. But it's a 3310. Again, on Holleys, we have the list number up here on the choke horn. We can look right here, and it'll say 3310. Sometimes there's a -1, -2, -3, anything like that. Again, that's just linkage and little minor little things. But they're all the basic 3310 carburetor, which is a dual feed inlet vacuum secondary carburetor. It's got center hung floats right here, where the floats inside are pivoting up and down, forward and back, not off to the sides. This looks like a double pumper to a lot of people. It is not a double pumper. Just because it has two gas inlets over here where the gas line comes in, okay, that doesn't make it a double pumper. It only has one accelerator pump here. There is not one on the rear float bowl. So this is a single pumper carburetor. It's a vacuum secondary, which again means if we floor it off the line, only the primary is open. The secondaries get pulled open by a vacuum signal. And again, you cannot just put a bolt in the side here to make this a mechanical secondary carb. You just get an extreme lean condition. So a lot of people don't understand that on vacuum secondary carbs, you can tune the secondaries when they come in. You can make them come in sooner, you can make them come in later by changing springs inside the secondary actuator right here. And that's the diaphragm inside, and there's a spring tension on it. We can get spring kits, which we'll show you in a later segment of this series right here, when we're modifying carburetors, how to do that and how to put quick chain kits on and stuff like that. Let's look at some other features of this carburetor right here. Of course, just like most other Holleys and most other Holley designed carburetors, we have the accelerator pump up here, the accelerator pump linkage, of course the regular throttle linkage where your accelerator pedal hooks onto. We come on over here, here's the idle screw right here, adjust the idle. We come on back, we have the rear bowl, there's a rear float. Underneath here we have a vacuum port. This is manifold vacuum, again for like a PCV valve or possibly for power brakes or anything like that. We have the rear bowl inlet right here. This feeds the gas directly into the rear bowl. Here's a sight plug right here. That's what we take out to adjust the float level. We'll get into that a little bit later. The secondary vacuum pot right here. This is what controls when the secondaries come in. We have the choke linkage right here. And this is a manual choke carburetor. This is the least expensive way to buy them. And the reason we use a lot of mechanical chokes is because we just pull the choke off. We pull the choke plate out, we slide the linkage out, and just get rid of it. Because most performance vehicles, they're fair weather vehicles. We don't need chokes on these things. If you don't want to do all the work to do that, we take a little rod like this, just a little piece of welding rod, or this right here is a little piece of aluminum rod that we have, and we can run it right through here, right on in here, and into the side of the choke actuator. Slide this in, we can cinch it down. I'll show you what it looks like when it's done. When we cinch all this down, what that does, it prevents the choke, when it's cinched down, from slapping shut. If you just leave it alone and you don't do anything to it and you don't hook it up, what can happen is you get on a throttle real hard. Sometimes when you're on the throttle and you got full throttle and all that air is going through there, these things will snap shut on you and the car will go, and it'll die because you flooded the thing out. It can't get the air in there. So sometimes we'll lock these open with a little piece of rod like that and just cinch it in place and you're done. All right, let's continue on looking at more features of this carburetor right here. Just like the other carburetors I showed you, this has a vacuum port up here, and like most Holleys, has one right down here. Again, this is above the throttle plate, so it's ported vacuum, which again would go to vacuum advance. This one right here would be to an automatic transmission. If you're not using a vacuum advance or you're not using an automatic transmission, just plug them off, no big deal. We have a sight plug up here to adjust the level of the, or to check the level of the front float bowl. And we have the needle and seat right up here for the front bowl, and the needle and seat in the back here for the rear bowl. Basic Holley stuff. Most Holley carburetors and Holley designed carburetors use this very same setup. We can look at some of the features inside. It's hard to see with a choke plate. When we get to others, you really get to see them. But you look inside right here, and we have right down in here the squirters. We have the boosters right in here. These are straight leg boosters. Some are down legs. You'll see some of these other carburetors. Some are annular discharge. We're going to show you that in a little while. But these are straight leg boosters. We have these two little tubes right up here. Pretty much all Holleys have these too. I'm taking the opportunity to show you these. I didn't show you on the first Holley because they weren't really prominent on the first one. These are vent tubes for the floats. This is just the vent tube for the float to be able to breathe air inside and out of there, right in here. Sometimes when the floats are too high, you'll actually get fuel coming out of these and dumping down in the carburetor. We'll get into that when we get into tuning and stuff. But these are the vent tubes. Down inside here we have air bleeds for the idles. Right inside here, you should be able to see there's some air bleeds. In fact, I'll show you. This is the body right here of a 3310. This is an older version before they started bright zinc plating these. This is actually a 3310 body right here. So I'll show you a little bit more on this. You can flip this up, it's easier to see. Of course, we've milled the choke horn off here, which makes better breathing. A little more airflow into the carburetor, and just more power increase. It's just little tricks we can do here and there. But right here we have the low idle air bleeds. We've got other air bleeds right here. Here's the boosters. It's easier to see in here. Here's the squirters, and again, when you give it the throttle and it squirts the accelerator pump, or activates the accelerator pump, it squirts fuel right through these right here to give it that off-idle extra fuel right when the throttle plate's open, so you don't get that lean condition. This compensates for that air coming in with fuel squirting out of here. If it was a double pumper, there would be a squirter back here. Being that there's no accelerator pump on the back bowl, there's no squirters right here. We do have boosters back here, because once the secondary is open, it starts drawing air through there. It siphons fuel right out of these and atomizes the fuel right on down through the carburetor. It's one thing I want to show you about carburetors too. Not all carburetors are just, actually I should say no carburetors have just holes in them, okay? Carburetors have what they call a venturi. And underside here we can see the actual venturis. We're working on vacuum signals with carburetors. And what we're talking about with venturi, we can see that the hole right here is quite a bit larger than the hole down inside here where it barely fits. This is the venturi effect. As air comes down, kind of like an airplane wing. You got a flat bottom and a rounded top side. Airspeed over the top is a lot faster than air on the bottom. It creates lift. Well, this same thing happens in here. If you notice the throat right here, it actually gets small. So as the air comes through, it creates different air speeds in here and different vacuum signals, which helps draw air and fuel through these boosters. Without that venturi effect in there, carburetors really wouldn't work. They just you wouldn't get much low pressure and high pressure areas inside, and you really wouldn't have a carburetor. The 3310 right here, we use these on pretty hard performance motors, 400, 450 horsepower motors. I've used them on motors that make upwards of 500 horsepower. It's a bit small for something like that, but 450 area, somewhere like there, on street motors, especially with an automatic transmission or a heavier vehicle, these vacuum secondaries are, bar none, just the way to go. Pull it off the shelf, it's ready to rock and roll. Of course, they need a little fine adjusting and stuff by the air-fuel mixture screws. We have those right on the sides right here. This controls the left side of the carburetor. This controls the right side of the carburetor. We'll get into how to adjust those a little bit later. All right, let's talk about what the 3310 carburetor would be used for. The 3310, again, was originally a 780 vacuum secondary. Now we call it a 750 vacuum secondary. But it was designed for the late 60s SS396 Chevelles. And I want to point out something right here, that the big three manufacturers, Ford, Chrysler, and Chevy, they chose to use these carburetors on probably about 80 to 90% of their muscle cars. And one reason I'm bringing that up is there's a really bad wives' tale out there that Holleys always need adjusting. They're always going out of whack, or you always got to tinker with them. That's just BS, okay? I mean, the big three wouldn't have chose these types of carburetors for their vehicles. I mean, I've seen Holleys on motorhomes. I've seen them on industrial trucks where they have governors and stuff on them. All the tri-power Corvettes, the 427 tri-powers, 3 Holleys. Shelby's, Holley's, Z28s, you got the 68 MO Z28s with the 302s. Holley's, you got the 69 DZ 302 Z28s. Guess what it had on it? Holley's. A lot of the Chryslers and vehicles like that had Holley's on them. I mean, if they were really needing that kind of adjustments or going out of whack all the time, these big three, the big three companies, they're not stupid. They wouldn't have chose a carburetor like that. And you still have muscle cars running around out there with Holley's on them that haven't been touched. So really, it's just, nothing could be farther from the truth. Really what happens are people don't change fuel filters, or they take a carburetor out of the box that's got cardboard inside of it and stuff like that. They don't know what they're doing. There's a lot of things like that that have factors in why a carburetor might not run right, or there's maybe possibly a defective carburetor. But really, it's not true that you have to keep adjusting these things. Once these things are adjusted, if nothing's wearing out, bending, flexing, or breaking or anything like that, there's no reason for the carburetor to go out of whack, or if there's no dirt getting in or anything, there's no reason for it. It's a great carburetor. We use these on some of our 450 horse small blocks, and they work real well. We use them on 400 horse motors, both Fords and Chevys. We use them on Pontiacs and Chryslers. It's a dynamite street carburetor, especially for your average street car where you have an automatic transmission, you're not running 488 gears in the rear end or anything like that. You got your 300 gears or 325s. You got a lower stall converter, even a higher stall with 3,000 RPM or something like that. These work dynamite. If you're in a race car where you got 513 rear gears and you got a manual transmission, you're launching off the line at 7,000 RPM or something like that, then the double pumpers work real good. But this carburetor keeps the air velocity feeding the motor at a high rate of speed, so the acceleration of a factory motor is really good with a vacuum secondary carb like this. And if the secondary is open at a different time, you simply put the different springs in here and adjust it to where you want it. Once it's done, you're done. Great carburetor, good bang for the buck. This is a real good one for you. All right, the next carburetor we're going to cover right here is a HP series Holley. This is a serious performance carburetor right here for some serious motors. It's a double pumper. It's a 4150 model. This is an 80528. If we look over here on the side, it says right here, should say 80528, and this one's a -2, which again is just a linkage or little minor features of the carburetor. It's a 4150. It says 4150 right here, and the reason it's a 4150 is it's got the center hung floats right here on the float bowls, typical of most 4150 series carbs. This one though, if you notice, we couldn't look on the choke horn for the list number. There is no choke horn. As you can see inside here, it's all nice and smoothed out for better airflow, higher velocities. More flow to the motor means more power. These come custom tuned from the factory. I mean, these are out of the box, awesome carburetors. Of course, on any carburetor, you need to do a little bit of jetting. It's rare that you pull one right out of the box and it's ready to rock and roll, but they're close. This one, though, has a lot of other features that most double pumpers don't have. And some of the features right here, obviously the choke horn's already gone. Or if we compare it to this one over here, we've had to mill the choke horn off. Okay, and that gives us better flow. This one's already done. It already comes from the factory that way. It's real nice. Some other features right here, if we look inside, this has down leg boosters. Of course, here's the boosters right here. And what that means is they drop down inside the venturi area there. And remember, I showed you on the other body right there, the venturis narrow down right here to increase the airspeed, which increases a vacuum signal going through the carburetor. It's what we call the venturi effect. Well, these down leg boosters drop the booster down inside there where the air velocity is a little bit greater. Just works a little bit different, atomizes fuel at a different rate, pulls through the main jets at a different rate than a straight leg booster. There's little differences between each carburetor for different applications. The techs at Holley and other carburetor manufacturers, when they make certain carburetors for certain applications, they do little modifications like that to make it best suited for the application that you're using. For this application, for some serious motors, the down leg boosters tend to work real good. Another thing we can see on this right here, these are the low idle bleeds right here. This is where air is drawn in at idles, are these little outer guys right here. And if we notice, they're a little different looking right here than on some carburetors. That's because they have a slot in them and they're removable. And the reason they're removable is some of the carburetors, we'll go to this one right here, this was the body of a 3310, these are the air bleeds right here. This is where air is drawn in at an idle to mix the air-fuel mixture for the idle circuit. And this is where the air is adjusted through the air-fuel mixture screws on the side of the carburetor right here. This controls the amount of air being drawn in here and amount of fuel coming through the carburetor. The nice thing with these is they are adjustable. we can pull them out and change them. A large cubic inch motor is going to require X amount of fuel and air at an idle. Well, sometimes you don't have enough adjustment on these little guys right here to make it idle nice and smooth, and sometimes they're just too rich. You're not drawing enough air through, yet the fuel inside is metered by a fixed hole size. So sometimes we need to increase these right here to let more air through to lean out the idle mixture. Well, on earlier carburetors like this, we can't because it's fixed. So what we need to do is we take a drill bit and a numbered drill and we go inside and we drill these out 2 or 3 thousandths at a time, oversized to let more air inside there. You don't have to do that with this carburetor. It's already done because it's adjustable. You can pop these out and pop a different one in. You're not drilling a hole. Because if you drill a hole and you go a little too big, you're done. You can't go back in and braze it up or anything. It's kind of a pain in the butt to pop it back out and pop a new restrictor back in there and start over again. It's simpler with adjustability like that. Let's look at some other features of this carburetor here. This is a double pumper carburetor. We've already talked about single pumper carburetors or vacuum secondary carbs that only have one accelerator pump. This has two. It has one on the primary bowl side right here that squirts fuel out of the accelerator pump here through the squirters right up here. But this is a double pumper, so there's also a pump back here. That means when we open up the secondaries, it squirts fuel out of the second squirter back here. And what that means is, we've already looked at vacuum secondaries. When you open up the throttle linkage, only the primary is open. When you open up this is why they call it a mechanical secondary. You open up this one, that's as far as it goes for the primaries. That's about, a third of throttle, maybe half throttle. Open it the rest of the way, and they all open up. Okay, that's mechanical. What happens is, though, as I explained on the vacuum secondary carburetors, these mechanical secondaries, when they open, it's also squirting fuel out of the rear squirter right here. When you do that little bolt trick I was telling you over here that some idiots think that they're, that they really know something, that they're doing something great to their carburetor, there is no fuel squirting back here. Double pumpers have it back there, so you don't get that extreme lean condition right there and get a real bad hesitation and lean the motor out. So this has two pumpers, which means you got the primary pump that'll open there. When we open up the secondaries, it'll squirt fuel right out of here. So it's double pumper and 4 squirts of fuel, also known as a mechanical secondary. This is also a dual feed inlet right here. It's got two gas inlets right here. These have them on both sides. These are the open ones on this side. Race carburetors sometimes have them on both sides. If you notice over here, these are plugs. That way we can plumb fuel lines in on either side. It doesn't really matter on what side. Sometimes you'll notice some of the carburetors on some manifolds are mounted sideways, some are forwards. So on sideways mounted carburetors, you might want the fuel lines to come in from a different side to clear linkages or to clear the manifold. Let me tell you a little bit about that too. Why are some carburetors mounted sideways? The reason they're mounted sideways is these floats inside here are pivoting up and down this way. So let me turn it this way. They're pivoting up and down this way. This is what controls the fuel level inside the bowls. So as fuel enters the inlet right here and goes past the needle and seat, the float comes on up, and when there's enough fuel inside there at the correct level, it closes the needle and seat off, and it keeps a certain amount of fuel inside here. Okay, the back one does the same thing, only it's pivoting this way. All right. Well, in race cars and extreme race cars and stuff, the acceleration when you go forward, this bowl right here is as you're going forward, the inertia, the bowl is just kind of sitting, or the float is just kind of sitting there. The back one here, though, tends to want to rise as you're on the throttle and the car launches real hard. This back one rises. Well, that starts letting fuel in there. What will happen is sometimes it'll slosh out of the front tube here, and this back one right here will fill up because of the fuel pressures we're running. It'll fill this up, and you can start flooding and stumbling. So you'll see some carburetors mounted sideways, like on tunnel rams, sometimes blowers, manifolds like that. They'll actually mount them sideways because as the car is launching forward, the bowls are pivoting, or the floats are pivoting this way. There is no forward and back inertia involving flooding the carburetor out or starving the carburetor out, because inertia is not going sideways to affect the bowl level or the float level. It's forward, and forward motion doesn't affect movement this way. It would affect it this way. So that's why you see some carburetors mounted sideways on serious race motors. You see pro stock motors, pro street motors, and things like that. They are mounted sideways for a reason. It's not just because it looks cool or anything like that. Let's look at some more features here. This right here is the throttle linkage. Of course, it activates manually to the secondary linkage. We come onto the back side. Here's the rear needle and seat right here. Come on this side. Here's the linkage right here that activates the rear accelerator pump. Of course, there's a vacuum port right here. And if we notice something, what's missing? No ported vacuum for vacuum advanced distributors. There is a vacuum port on the side. Sometimes on these carburetors there's one, sometimes there's another, right side by side. There's a port right here also. This one, instead of two side by side here, there's one right under here, and that's also for like transmission or anything like that, a vacuum gauge to show you what kind of manifold vacuum you have or anything like that. Here's the sight plugs right here. This is what we open up to see the float level inside there. And what's different about this carburetor here, to a lot of carburetors, we have the air-fuel mixture screws right here for the primaries. That adjusts the right side of the carburetor. This one right here adjusts the left side of the carburetor. We look in the back though, we also have rear ones. Okay, there's one on this side, one on this side. This is what we call a four-way idle circuit. Okay, it's got, or some people call it a four-corner idle. That means we have four adjustments right here. The reason we have that is a lot of big cubic inch motors need a lot more fuel and air at an idle sustain, 450 to 550 cubic inches. So we need different or more idle circuits in here to allow enough fuel and air to get into the motor. Plus, race motors have a lower vacuum signal at an idle. Some race motors and performance motors only idle at 4 inches of vacuum, 5 inches of vacuum. Your average medium street motor might idle at 9 inches of vacuum, somewhere's right in there with hot cams. That's all because of the overlap of the camshaft. So sometimes there's not enough idle vacuum to draw through these idle circuits right here, to draw enough vacuum through to actually sustain the idle. So they'll put 4 of them in there to help flow a little bit more air a little bit easier. It takes less vacuum to do that, helps the motor sustain an idle. We talked about carburetors mounted sideways and carburetors mounted forward and stuff on different applications for high acceleration cars and things like that. Sometimes you'll see on race cars, you'll have a little piece of fuel line going over this bowl vent right here and this bowl vent right here. And what that does is sometimes cars have enough acceleration forward to not really mess with the float level so much, but it'll slosh fuel out of the front bowl and it comes up this vent tube and dumps down the carburetor. And that's when you see a car launch off the line and go whoop, whoop, and take off, and it dumps fuel down there and it hesitates and stumbles and then clears out and goes. What this does right here, it transfers the fuel to the rear bowl. Instead of dumping it down the throat of the carburetor and flooding the engine out off acceleration, it'll transfer it back. This is not necessary for a street car and street tires. I mean, unless you're tubbed out and you got some, 20-inch wide tires on a 4-link rear suspension or something like that. If you got some street tires and they're X wide or anything like that, you're not going to get enough acceleration or launch off the line to require something like this. But you will see transfer tubes. I just wanted you to know what those are for and why some guys have those. It just transfers fuel from the front bowl, from the slosh of this thing accelerating forward like that. It'll slosh it right out down the throat of the carburetor. This just prevents it, puts it back here so the fuel can be used. Let's show you a couple other things here. I want to make a comparison here between a 3310 carb or a typical vacuum secondary carburetor and a double pumper. They do look similar, but there are differences. Vacuum secondary carburetors have a jet plate right here. That means the main jets, this is where the main jet plate is right here. The main jets are screwed into this plate inside the carburetor, as is the power valve. And we'll get into that, what those things are when we get into later on in this series right here. If you notice, there is no jet plate in the back here. It's because they use a metering plate that meters the amount of fuel coming in back here. Double pumpers, though, have a front jet plate with a front power valve, and they have a rear jet plate, which means they have rear jets also. What that also means is this is a slightly longer carburetor than this one. To the naked eye, a lot of people see these and they go, oh, that's a double pumper. And one thing we explained that earlier, it's not. It's got single pump, but just the overall look of the carburetor looks like a double pumper. This is a true double pumper, especially with the 2 jet plates. What you run into on this are fuel lines. When we get our typical fuel lines here, these are your typical chrome off-the-shelf fuel lines for these carburetors. They look very similar, but they're not. If we put them side by side, there is a definite difference between these two in length. Reason is, that's the space of the rear jet plate on double pumpers and the missing rear jet plate on vacuum secondary carburetors. So when you're getting fuel lines for your carburetors, you need to make sure you don't say, oh, it's a dual feed inlet carburetor. Both these are dual feed inlets. You need to know which length it is right here. The double pumper has a little bit more length on it. That way it lines up with the float bowls nicely. You put it over here, compare it to this one, it hangs off the back side of the carburetor right here because it's missing this jet plate. So you need the correct fuel line for these types of carburetors. Just because it's a dual feed inlet doesn't mean that there's one fuel line for these. So just take note of that when you're purchasing a carburetor and getting your fuel lines and everything. Make sure you know if it's got 2 jet plates or if it's just got a metering plate in the back. And pretty much all vacuum secondary carburetors come with just a metering plate in the back. All right, what we have right here is a Demon carburetor by Barry Grant. These carburetors, they're basically similar to a double pumper Holley. They're not the same, but they are on the same principles. The real features of this carburetor right here, as you can see, it's a different color than a Holley. It's made out of billet aluminum, where most other carburetors, including Holleys, are usually made out of like a zinc aluminum alloy. This is all billet aluminum, which means it's a little more durable on wear and tear and things like that. It's basically a bulletproof carburetor. It's got a lot of the same features as, like I say, your typical double pumper carburetor. When you first notice it, you say, yeah, it's got center hung float bowls right here with a needle and seat. It's got very similar internals. We've got right up here we have down leg boosters. Inside here we've got the squirters. We've got the air bleeds for the idle circuitry. We've got pretty much everything that any other typical double pumper has. We have sight plugs over here. Of course, these are clear ones right here, so you don't have to actually remove a sight plug to see the fuel level. They have a clear one, so you can actually see the float level inside there. Double pumper, here's the secondaries. Here's the rear accelerator pump. We come to the front. There's the front accelerator pump, hence the double pumper. We have the linkage. There's the first stop right there where it actually stops. You can feel the secondaries wanting to come in, and we continue with the linkage, opens up the secondaries, squirts the second shot of fuel. So it's a true mechanical secondary double pumper carburetor. Let's look at some other features on here. This also has four-way idle circuits. It's got a front jet plate that's hidden back here. You can just barely see these. The bowls actually come around and cover these, but the jet plates are back inside here. And you can see the little color difference right there between the jet plates and the actual bowl. And that's what these are attached to, the idle circuits right here, or the air-fuel mixture screws. Of course, we have them on the other side. And let me tell you a little quick thing. We're going to get into this in tuning too, but while I'm thinking about this in this segment, the air-fuel mixture screws control the air-fuel ratio that's feeding the motor at an idle. They do not lean out the carburetor or anything like that once it's running. Once you crack that throttle open, these don't work. They only work at an idle. So if you want to lean your carburetor out or richen it, all these are going to do when you turn these is do it at an idle. As soon as you crack the throttle open, the transitions in the carburetor, you're not on that circuit anymore. You've changed circuits. Okay, so just a little quick thing. I'll probably mention that later on. You're going to find that I'm going to be reiterating on a few different things as I go along here, just to be sure I get the points across. And in case you missed it earlier or you missed it in a later segment, it'll all be included in there. Let's look at some other little goodies on here. Here's the idle screw right here. Most of them are right here. Again, it does the same thing. If you screw it down in, it'll pull the linkage back, create a little more of an idle, a little more throttle there. You back it back up, it'll drop the throttle linkage back down to lower the idle. Some of these carburetors, though, if we look over here, they have also an idle, looks like an idle adjuster right here on the secondary linkage. And you say, what the heck's that for? Well, some engines, low vacuum engines like, race motors and things that these types of carburetors are intended for, sometimes you can't get enough idle over here, or idle movement when you screw the throttle plate screw in here to open up the linkage enough to get a good idle. Sometimes you get off the idle circuit. So what you can do is you can adjust this down a little bit, and what it'll do is it'll actually open the secondary throttle plates a little bit, just enough to let a little more air inside there to help the engine idle. That's just a little feature. It's just more tunability. Some carburetors have them on the outside right here. Sometimes you flip underneath, and they'll have a little set screw down inside here to adjust it. This is more convenient when it's up on top like this, because obviously you don't have to take the carburetor off, take a little micro screwdriver and get in there to turn it. It's convenient to have it up on top like this for quick adjustments, or just to try it to see if it works quickly. If your engine's not idling, you've tried adjusting and you can't get it to idle, it's nice to be able to stick a screwdriver in there and go, well, let's give this a little try here. The main thing to remember is with four-way idle circuits like this, you want everything even. You don't want the fronts to be way open and the backs totally closed, or vice versa. Everything should be even. All right, let's look at another little feature of this carburetor right here, something that's actually not there. What you notice it doesn't have is a choke. This carburetor came that way. We didn't remove the choke off this. Like I said earlier, a lot of performance carburetors don't come with chokes. That's why we remove them on a lot of the Holleys. A lot of times the first thing we do when we get them is take the choke assembly off. We don't use those. This one came that way. If you notice, the Demons, they have a really low choke horn right here. The choke housing is actually quite a bit lower than other types of carburetors. This just creates a little more air fuel or air going into the carburetor to make a little more power. Of course, it's not milled off, but it's low enough where it still makes good power. One feature this carburetor doesn't have, but other demons do, are changeable air bleeds right here, the idle circuit air bleeds. This one right here has a kind you have to drill out. Other ones do have changeable ones in there, just that this particular model doesn't have that. We can look at a couple other features of this carburetor right here. We'll flip it around. On the back side, it does have a port right here for like a PCV valve or a power brake booster or something like that. A lot of performance engines, though, we don't run power brakes on performance motors most of the time because the vacuum signal is not high enough to do that. So a lot of times this is just blocked off, or it's going to the PCV, to the positive crankcase ventilation valve. It does have two vacuum ports over here, right here. They both take at different areas inside the carburetor. So you got two different vacuum levels right here for ported or for manifold vacuum. And we look underneath here, and even though it looks similar to a Holley, it doesn't have the front port here. They've put them both on the sides over here. Most of the time on most race carburetors, pretty much all the vacuum lines are plugged off. Sometimes we use a PCV on the back. Sometimes we use other types of evacuation systems like vacuum pumps and stuff like that. So we don't even have any of the vacuum lines hooked up. This is a dual feed inlet. It has a different type of fuel line here. I prefer this type of fuel line to the chrome ones that we saw on the earlier carburetors. You can certainly put this type of fuel line on any of the carburetors, but the reason I like these, the chrome lines, I got to say, they tend to leak. It's hard to find a good chrome line unless you spend a really good dollar on getting a good high quality one. The cheaper ones leak. These don't. These are AN fittings right here. This is number 6 fuel line right here, and they use the tapered seat AN fittings. A lot of the, you notice the anodized fittings like this, the aluminum, you see them on a lot of the race cars for oil lines, fuel lines, air lines, all kinds of things like that. These don't leak. You can use them over and over again. These are cinched down real tight. Very few chances of getting a fuel leak. When you use the chrome lines, they're kind of notorious for leaking up here, and you got to tweak on them. Sometimes the chrome chips off, and it creates a little bit of a leak. If you got the budget for it, it's a good way to go with one of these. And you can have a single line like this into a hard fitting. You can have 2 fuel lines coming off. I mean, you can configure these things in any way you want. With the chrome lines, you're kind of stuck with what they give you, and sometimes that's not the ideal situation. These, we can come off with a 90 or a 45 on any type of fitting like that. Sometimes these are a nice way to go, and they are pretty well leak-free. What we have right here is the mighty Holley Dominator carburetor. This is a giant carburetor, as you can see. These are definitely not for street use unless you've got a huge amount of cubic inches. And I'm talking, 572, 614 cubic inches, 700 cubic inch motors, which you'd only find on like a serious pro street car, or idiots like me that drive cars like that on a street, which are basically race cars with nothing but headlights and a registration. Doesn't mean they're street legal. It means they're street registered, but not exactly street legal. So pretty much guys like us are the only ones that run this kind of stuff on the street. Otherwise, you'll see guys running these on the racetrack. You usually see a pair of these mounted sideways on a sheet metal fabricated tunnel ram on the pro stock cars and things like that, or very large cubic inch drag race motors. That's just because these things are so big. This is a 1050 CFM. It's 1050 CFM out of the box, ready to go. That's a lot of CFM. It takes a lot of cubic inches to utilize that kind of airflow. But let's kind of go over the features of this anyway, and I'll show you why we would use this and why we wouldn't use this. Just like any typical carburetor, it's a Holley design. It's got center hung float bowls on the ends, which are typical of any double pumper. With the vent tubes, we have the squirters right here, squirts the fuel right on in. Here's the boosters right down here. These are different boosters though. These are annular discharge boosters, and what that means, they're actually hollow. You can actually see holes inside here. At different angles right here, there's actually a series of holes. Fuel comes in from the sides. This whole booster is hollow. And what that means is when we are on the throttle and air is coming through here and drawing through these boosters out of the main jets, it actually discharges in a circumference area rather than just out of one little area they're drawing through. It just atomizes the fuel a little bit better as it goes through, but they're called annular discharge. They're basically hollow. Some double pumpers use those, some Holleys and Demons and things like that. They will have annular discharge boosters just for some street use or things like that. Like I say, there's differences between each of the carburetors that the manufacturers do that work better like on a heavier car or on a lighter car with real tall rear end gears or real short gears, like short gears like 513s on the street or something like that. It depends on the acceleration of the motor, the load of the motor, the weight of the car, things like that. stall speed on the transmission, or if it's a manual transmission. All these little tuning adjustments that we can do help the carburetor make the engine make its power and RPM ranges. Again, here we have idle bleeds that are removable, and of course there's two of them. These are usually large cubic inch motors that have these things. So there's a couple extra ones right here, but these are removable. You can change them, different sizes, different circuits inside to do that. Other features, I mean, we have the double pumps right here. There's one right here on the primary side. There's one back here on the secondary side. If we look at the housing right here, it's a little thicker than a typical double pumper. And reason being for that is these are 50 cc accelerator pumps. Most regular carburetors, when you give it the throttle, they squirt 20 to 30 cc's of fuel. This is a 50 cc accelerator pump, means it pumps a lot of fuel. So when we give it the throttle, there's a long, big shot of fuel squirting out of these. Instead of just a squirt, it's a it dumps it. Okay? So it's not only the fuel that these things dump, it's the air they let in also. And that's another thing I want to talk about with not just this carburetor, but especially this carburetor, but also most double pumpers on the street. You know, you have to figure double pumpers were designed for RPM use. That's why you saw them on road race motors, like on Shelbys. You saw them on Z28s, early Z28s, vehicles like that are at RPM. You know, they usually came with 411s from the factory or 389 gears from the factory. You didn't find them in grandma's car that had 279 gears in the rear end and a transmission with a 1200 RPM stall converter. They don't work good on those kind of things. They're made to get at RPM, launch and go, not to get to that RPM. The vacuum secondary carburetors, they're designed to get up to that RPM. But you look at most of the cars with double pumpers, they get to that RPM, then they launch, or they're on a road course and are already driving past the starting flag at 60 miles an hour in formation. Then they nail the throttle. Well, the engine's already at airspeed. You know, if you saw the cars with factory cross rams and stuff like that, where you got two 600s or 650 Holleys mounted side by side on it, like a say a 68, 69 Z28 with a factory cross ram setup, things like that. That's a lot of fuel and air being dumped in there when you nail the throttle, and a small cubic inch motor just can't utilize that unless it's at RPM already. So if you're already on the track going 50 miles an hour in formation, then you nail the throttle, it picks up speed and goes. But driving around town from stoplight to stoplight, you nail the throttle. It's what we call flushing the toilet. And what I mean by that right here is when you open this throttle linkage right here and you open all four, it's like flushing a toilet. Okay, it lets nothing but a big shot of fuel and air in there, and the motor can't take it. Remember, motors work on vacuum. And what I mean by that is the motor's just basically a big vacuum pump. It draws air through by the pistons going up and down as they go, and the valve actuation via the camshaft and everything, as the pistons go up and down, it's drawing air inside. Well, the air, the only thing feeding it is the air that it draws through with the gasoline mixed with it. If you stop the airspeed, the motor can't rev. It can't go anywhere because you've stopped the airflow inside the motor. Well, just like all vacuums, if you take the nozzle off the end of a vacuum cleaner and just open the hose up, you can't vacuum the floor very well. You need to put the attachment on there with the small hole, and boy, you can suck flies out of the air with a shop vac with the small attachment on it. Well, the same thing happens to this. When the throttle plates are closed, it's closing off so that the engine's trying to suck air, but it can't, so it makes a real high vacuum signal underneath the throttle plates right here. As soon as you open this up, nothing. And I talked about this earlier. That's when you hear about people that, yeah, I got to feather the throttle off the line. You know, my car runs real good as long as, I got to feather it little by little, and once it gets going, I can floor it. That's telling you the carburetor's wrong. You shouldn't have to do that. Well, this is really wrong. You wouldn't put this on a small cubic inch motor, a 350 or a 327 or a 302, whether it's a 302 Chevy or a 302 Ford or anything like that. You'd probably stall the motor. If you put this thing on there and floored it off the line and flushed the toilet, it would probably just stall. Because all the airspeed would just drop. It's too much of a mass. So we need to keep a velocity in there. Otherwise, it can't feed through the runners and feed the motor. So that's what we run into with this kind of stuff. So you only see these on very large cubic inch motors at the track. You rarely see these things on the street. And if they are on the street, like I say, it's a like a pro streeter. The guy's already got 513 or 536 rear gears. It's basically a race car with a street registration and headlights, and that's about it. There's not much difference between that and a true race car. But we don't use very many of these on any of our street motors or anything like that. We use them on hardcore race motors. It's even pretty rare on those. It has to be a large cubic inch motor for us to even use one of these on those. Otherwise, we opt for like an 850 carburetor or a 750, something like that. And on smaller cubic inch motors, we'll go smaller, 600, things like that. You have to think about CFM, cubic feet per minute. This thing flows 1,050 CFM. For a 350 cubic inch motor to flow 1,050 CFM, it's got to be spinning about 12,000 RPM. I mean, there's not many 350s that'll go up to 12,000 RPM. So to utilize what this carburetor can do to it, can feed the motor, it's way too big for beyond the capabilities of what the motor's even using. Let me give you a quick example. Think of NASCAR where they put the restrictor plates on. You know, they run a 390 CFM restrictor plate, and they're still running around the track at 8,000 and 9,000 RPM, making 700 horsepower on the restricted motors. I mean, that's a lot of power on 390 CFM. So you're telling me that you got a NASCAR, a 355 cubic inch NASCAR motor that's restricted to 390 CFM, and it'll blow the doors off 90% of the street cars out there, even pro streeters. I mean, that's 700, horsepower that they're making on those things. So when you see a guy running around with a giant carburetor like this, think of the NASCARs that have those restrictor plates and think of the power they're making, and think of what this guy's doing when he's flushing the toilet and he can't get off the line. It doesn't take a giant carburetor to make horsepower. It's all about flow, fuel delivery, maintaining an air-fuel ratio that's adequate for that motor. This thing right here would just deliver way too much fuel. It would open up the throttle plates way too big. You'd lose the air velocity and the motor would just, it would be a turd. And the object of building performance motors is not to have a turd. You want something that actually goes. So you probably won't see many of these carburetors yourself out there unless you're building something that's really radical like a drag car or anything like that that's going to be a serious dragster. All right, we're going to take a look at this carburetor right here. This is just an old one we've had laying around the shop for a while, but I wanted you to see one of these because you don't see these very often, but you will see them occasionally on boats and some older vehicles. And it looks like a regular 600 Holley, like a 600 CFM vacuum secondary, only it's not. There is no vacuum pod over here, and this is a very unique carburetor. This is called a 660 center squirter. These were designed for like tunnel rams. They're designed to be used in tandem, like on a tunnel ram or a cross ram type setup where you have 2 4 barrels. Only the problem was these really didn't work. This is kind of yesterday's technology. We're way beyond these types of carburetors today. But let me show you the features of these because this is a carburetor that's very unique to itself. This is the only one that's like this. It is a single pump carburetor, but it has a 50 cc accelerator pump on the front right here, which means it shoots a big squirt of fuel. The difference is on this one, if we look in, we don't have squirters here or here. It's right in the center, and it's a 4-way center squirter. Okay, so it squirts 4 bursts of fuel all at the same time. Right from the minute you crack this open, and this throttle linkage, right, this accelerator pump linkage is moving right here. As soon as you do this, and that's squirting, it squirts through all 4 of these simultaneously. So when you look down the throat of one of these things, it's a big shot of fuel. And there's also one thing you want to look at right here. The primaries and secondaries open almost simultaneously. There's very little part throttle on these things. Almost identical primary and secondary opening. That's not exactly ideal for keeping velocity up or launching off the line or getting to an RPM, like driving around town or something like that. I mean, imagine a pair of these on a vehicle right there. You stab the throttle off the line and all 8 barrels open up at once. You talk about flushing a toilet, that's serious right there. All the velocity's gone. You've dumped this huge amount of fuel in there, and the motor's like going, what am I supposed to do here? There's no air and fuel feeding me as far as velocity coming in through the heads and feeding the cylinders. It just falls on its face. A lot of guys use these on boats because boats, they wind up into RPM and plane across the water. But if you're using this on a boat where you're going to pull a skier out of the water, or a couple of skiers, the thing wouldn't have enough guts to get out of the water and plane because it'll dog down. The guys that use these usually have the dog problem off the line because you stab it and they're like, oh, it's too much. They got to back off and feather into it simply because all 4 barrels are opening up at once. That's not real good. But this is a 660 CFM center squirter. Just wanted you to see one. Again, this is just an old piece of crap carburetor I've had laying around here. Just wanted you to see one and have an opportunity to, in case someone ever says, hey, that's a 660 center squirter. You know what the heck they're talking about. What we have here is a 6-pack manifold from a 340 Chrysler. This is off the famed 340 6-pack cars from the early 70s. The reason they call it a 6-pack is because it's 3 2-barrels, 2, 4, 6 barrels. Basically what these did is you ran around on a center carburetor. So driving around town, you're just on this center carburetor right here. You activate the linkage and give it full throttle, and the secondaries, the front carburetor and the back carburetor would kick in after that. Now there's 2 types of these. both General Motors and Chrysler used vacuum secondary carburetors. And I can pull one of these off right here that's a little easier to pull off. These have a big vacuum dash pod on the back right here. That activates what we would call the secondaries on these things, which would be the center carburetor being what we call a primary carburetor and these outer tubes being the secondary carburetors. That opens up the outer 4 barrels, the 2 here and the 2 back here. They come on vacuum activated. The reason that worked so well was because when you floored it, the air velocity going through the center carburetor let the engine wind right up real tight and real fast. And when it needed it, it would draw off the outer carburetors and just go like a bat out of hell. Now Ford had this also, very similar setup. Ford called it the 6V system. Ford designates their carburetors as V, 2V, 4V, and 6V. And what that really stood for is Venturi, 2 Venturi, 4 Venturi, or 6 Venturi. Some people called these 6-packs, some people call them tri-powers. I believe Ford called it a tri-power also. The General Motors cars, I'm sure you've heard of a 427 tri-power vet. That's because they ran the same things. All right, so we just talked about the Ford with the 2Vs and 6Vs and 4Vs and how they designate the V series on the carburetors. The Ford 6-pack, though, is one of the only ones, of the Ford tri-power, is one of the only ones that used mechanical linkage rather than vacuum-actuated carburetors. And the problem with that was when you floored the throttle, all 6 barrels opened up at once. And that, again, we talked about flushing the toilet. That flushed the toilet. That worked real good on large cubic inch motors, but boy, if you had a small cubic inch motor with mechanical 6 barrels opening up all at the same time, that's worse than a double pumper 4 barrel opening up. And you know how much trouble most people have with 4 barrels stabbing off the line. They're like, oh, I can't do that, I got a feather. Once I get going, though, I can floor it. Imagine 2 more. That's worse yet. So let me show you something about this right here. How the 6 barrels, 6Vs work and tri-powers and stuff like that compared to a typical vacuum secondary carb. Much like a typical 4 barrel, when you open up the throttle on here, it opens up wide open, the car goes real good. When there's enough air velocity coming through here, it creates enough vacuum, ported vacuum, to start drawing off these carburetors and open up the other barrels. Much like a 3310 carburetor does right here. You floor it off the line, only the primary is open. When there's enough engine RPM and airspeed going through the primaries right here, it siphons the secondaries open and starts opening the secondary throttle plates. Okay, so it's on-demand power, which is really good because the engine knows when it's going to need the power. And if it needs a little help, you can adjust it via these springs. Well, when we have a double pumper, I talk about those right here. It's very similar to one of these right here. When on the Ford ones, when you stab the throttle and all 6 barrels open up, it's kind of like this. All 6 barrels open up. And on this one, all 4 barrels open up. And that's not exactly an ideal thing except for larger cubic inch motors. The 6-packs work really good on the street simply for the fact that on the Chryslers and the GMs, you're driving around on a 2-barrel around town. That works really good on 6-pack cars. On 2-barrel cars, though, a lot of people have a misconception that 2-barrel cars get better gas mileage than 4-barrel cars. And actually that's not true. And the reason being is, let me explain this right here. Let me grab this right here and show you. Here's the vacuum secondary 3310 again. We're going to use this as an example. Let me explain this, and because a lot of people right now, a lot of you are probably going, oh, he's crazy, there's no way. 2-barrel carburetors, most of them, because it's a 2-barrel carburetor, like you had a lot of the early vehicles, 390s, Fords, 360 Ford trucks, some of the early Chevy trucks and things like that, they had 2-barrel carburetors on them. The 2-barrel carburetor, though, some of them were 375, 350, 375, some were even 500 CFM. So you think about that, that's 500 CFM. So every time you give it the throttle and you want to drive, you're driving around on something that's 500 CFM. Every time you give it the throttle, it's 500 CFM. That's a lot of fuel and air getting in there. I mean, that's a velocity that you're losing. That's like a 500 CFM 4-barrel being opened up wide open. So a 2-barrel is kind of the same way. Let me explain this. When we look at the 3310 right here, this is 750 CFM. So let's think about that. It's 750 CFM, even at wide open throttle, but the secondaries aren't open yet. So what's half of 750 CFM? That's 375. So you're driving around basically on a 375 CFM 2-barrel, which is nice because you've got throttle response, you've got torque out of the hole to get the car launched and everything, and as the engine needs it, it will pull open the secondaries, and when they're wide open, this carburetor is capable of flowing 750 CFM. But for the most part, you're driving around on a 375 CFM 2-barrel, which is smaller than a 500 CFM two-barrel. And no matter what you do, as long as the throat sizes and the throttle plates are a given size and have a given CFM, you can say, well, just downjet the two-barrel. It's only got 2 jets. It has to meet the fuel with the air. You need to keep a constant 13.5 to 1 average air-fuel ratio, 14.5 for super economy. Some blown vehicles and nitrous vehicles, we get down to 12.5 to 1 air-fuel ratios on some of those things for a safety feature of the motor. So on a 500 CFM two-barrel, you're not gonna get that. I mean, you have to have a certain jet size to accommodate the amount of air coming in to maintain that air-fuel ratio. And if you don't, you're either too lean or you're too rich. These guys right here do the same thing, but it's less. Even though the carburetor's bigger, it's not as big as all 3 of these put together. So you're actually driving around with better throttle response and better drivability than you are with a two-barrel. And that's simply the reason why some two-barrels don't get as good a gas mileage as a single 4-barrel. Remember I said earlier too about Holleys always needing adjusting and they're always going out of adjustment and you always have to tinker with them? Hello, 1, 2, 3 Holleys. That's Chrysler's choice. Guess what the Fords are? 1, 2, 3 Holleys. Guess what the Chevys are and all the Tri-Power 427 Vets that are still running around out there? 1, 2, 3 Holleys. It wasn't just the Tri-Powers, there's a whole load of them out there with all the 4-barrels and stuff that are all Holleys. So most muscle cars came with Holleys, and how many muscle cars you ever see on the side of the road getting tinkered on all the time? A lot of them had 2 of them. All the Cross Ram cars had 2 Holleys. So, that's really a wives' tale about that. They are a good carburetor. These are very similar to a 4-barrel. They have the center hung floats right on here. They have the boosters right inside here. You got a sight plug on here. Very, very similar to any typical Holley carburetor, whether it's another 2-barrel or a 4-barrel. Of course, these look a little different. I mean, these are designed for a tri-power setup, but there's a lot of aftermarket manifolds that you can purchase, Adelbrock and many others, where you can just take 3 Holley 2-barrels, usually like a 350 CFM in the middle, and you can have outer 2 350s. Some of them, they run a 500 CFM middle and 350s on the outer. It just depends. Usually the center carburetor, sometimes you'll run a smaller one in the middle. They'll run a 350 and 500s or 500 and 350s. Depends on the setup that you're running. If we look at the carburetors right here, we can see that they're different sized. This one runs a 350 CFM center carburetor, and this looks to be like 500 CFM outers. Some people do this, and that's okay. Some use them all the same size, some don't. It just depends on the setup of the vehicle. All right, I thought I'd take this opportunity to show you something really kind of cool and fun here. You don't get to see these very often. This is a small block Chevy with Webers on it. These are 4 different Weber carburetors. This one actually is for a 66 Corvette. Let me tell you a little bit about these. These are kind of cool. Each one of these is a 48 IDF carburetor. And basically what that stands for, it's a 48 millimeter throat inside of each one of these carburetors. Each one is a double throated, like a 2-barrel basically. And of course there's 4 carburetors. Each one of these is a single carburetor with twin throats. These are really good for mid-range power and top-end power, like road racing applications, things like that. They're not the greatest for drag racing. That's why you don't see these on too many drag cars. But you did back in the 60s see these on GT40s. You'll see them on some early Corvettes. You'll see them on some Shelbys even. Little cars like that were more road race cars than they were drag race cars. There are other types of Weber carburetors. There are 48 IDA carburetors, and the IDA series, they're a little bit bigger, a little bit taller. They're a little more of a performer carburetor. We had to use these IDFs simply for hood issues. This is going in a 66 Corvette, so we have a hood issue that we have to be careful of with height. So we went with the shorter little guys. There is also another Weber carburetor that's made that you might have seen on some street rods and blower applications where they're actually sitting sideways. Those are pretty rare. You don't see those very often. You always see mostly downdrafts like these. Most of them are 48 millimeter, and that means the throat size in here. So that's kind of big. So you have to think about it. When you open a throttle linkage on this from a dead stop, you're opening 8 barrels all at once, and they're big. If you flip one of these upside down, the barrels on these are a lot bigger than like a typical 750 Holley. These are pretty big throats. So off-the-line performance is not the greatest on these unless the car is really set up for it. Geared properly, you're going to need lower gears. If it's an automatic, you need a better stall converter, a little higher RPM and stall converter. You also need to set the motor up a little different for these. These are touchy on vacuum, and big radical cams don't have a lot of vacuum. So you can't really use a big radical cam with these types of engines for driving around town. If the cam is properly set up with a little wider lobe separation, a little less overlap, not quite as radical, you'll get better throttle response and better drivability around town. We talk a lot about that in our heads porting and valve trains videos. If you really want to get into that, be sure to pick one of those up. There are some wives' tales about these, about tuning. Oh boy, you know, 4 carburetors, they're always going out of tune and everything, or how do you adjust them? They adjust like any other carburetor. They have air-fuel mixture screws on the sides over here, one for each throat. It's just it just simply adjusts the mixture of the air and fuel going down the carburetor, just like on a Holley or an Edelbrock or any other type of carburetor. But trying to sync all these up, it might seem complicated, but it's not. There's a simple little tool. This right here is called an AccuSync. Simple little air meter is all it does. Basically, air pulls through here, comes in through the vents right here and pulls through, and it has a reading right here of what the flow is. And you simply put this over one of the throats like this when the engine's running and just adjust the air-fuel mixture screw here until you get the highest reading. Then, of course, you move over to the next one and do the same thing. And then you go to the next carburetor and adjust them until they're all accurately synced, hence the name AccuSync. These are really neat. You don't get to see them very often. I thought you'd get a kick out of this. Well, we've covered the external parts of a carburetor already. Let's go to the inside and see what the internal parts are. And basically what we're going to do is rebuild this carburetor and go through all the phases and aspects of rebuilding a carburetor for performance use. The carburetor we chose right here has already been run, so it's not beautiful. It does need a rebuild. This is a tricked out 3310 Holley. It's a 750 vacuum secondary, but it's got a few modifications, and we're going to look at that first just so you know what we're working with right here. First off, the customer that has this right here opted to go with the, it's a little K&N piece right here that increases airflow inside the carburetor. They call it an air horn, basically, is what it is. And you saw on one of the other bodies earlier that I milled the air horn off, which increases flow. This kind of does the same thing. It makes it a flat surface on top for the air to increase its speed and velocity and volume inside the carburetor. Kind of an inexpensive piece that actually doesn't work too bad. Not a bad little piece. So that's what that little cookie is right there. We'll come over to this right here. For the most part, when you look at it, it looks like a basic 3310 carburetor, except for the fact, we talked about this before, double pumpers have jet plates on the front and on the back. Most vacuum secondary carbs don't have a jet plate, they have a metering plate in the back. This has been converted to a jet plate. We can see it right here. So this is basically the length of a double pumper carb. And you might ask, well, how did we get a jet plate back in there and why would you do that? Reason we have one back there, so we have changeable jets in the back, where when you change metering plates, it's kind of a pain in the butt. You got to change a whole plate. This we can quickly change jets. And it's an easy swap to do. There's a little kit right here you can purchase right direct from Holley. It's a 34-135 kit, and it's a rear jet plate conversion kit. And it comes with everything you need in there to convert your 3310 over to a rear jet plate. Simple little swap that you can do. All right, we'll look at some of the other features on this carburetor that have already been done. Flip it around to this side right here. We can see right here that the secondary vacuum dash pot and where the springs are and everything in there has been changed already. This has a quick change kit on it. It's kind of convenient because when you're going to tune a vacuum secondary carburetor and you have the springs inside there, it's kind of a pain in the butt to take this unit off because you have to undo all the screws in here, undo it here, pull it off, and you got to pull the diaphragm out. And it's really kind of a royal pain in the butt. When you get one of these quick change kits, we take the 2 screws out right here, these top screws right here. This little piece comes off, the diaphragm stays intact, we don't mess with that, and the spring comes out. And basically, I'll show you right here, we have a quick change kit that you can purchase directly. It's 20-59, and this comes with all the components in here that you need. Just basically the housing. There's the housing top, and the lid, and the little goodies, and you use your existing bottom piece right on here where the springs are in there, and they give you little seals and everything for it. Simple change, and I'll tell you what, it makes life easy when you're changing springs, tuning your carburetor. We go on right here. Here's the secondary diaphragm spring kit right here. It's the tuning kit for that. It's a 20-13 spring kit. It comes with various colored springs, brown ones, purple ones, there's yellow colored ones. They all have different tensions, and that will delay the time or increase the time of when the secondary is open, depending on how much air flow is coming through the primaries as to how fast the secondary is open. So if it's a small cubic inch motor, you don't want the secondaries kicking open too soon because you're flushing the toilet. But if it's on a big motor, You don't want them coming in too late, or you're basically running on a two barrel, it peters out, then the secondaries kick open. There's kind of a rule of thumb. Let me explain this. If you can feel the secondaries kick in, they're set too late. Okay, you should never feel the secondaries. A lot of guys go, boy, when you feel those secondaries kick in, it takes off. Well, that's telling you something right there. You shouldn't feel anything kick in. It should be smooth power from the point you stab the throttle right down to the floor, all the way on up until your engine makes its peak power, until you grab the next gear, and it should be smooth all the way through. If at any time you have to feather the throttle or horse around doing anything, or you feel it, take off and then kind of nose over and then take off again where the secondaries kick in, it's out of adjustment. That's incorrect. Okay, the next little cool thing I want to show you about this carb that's been modified is we've installed clear sight plugs on here. We've taken out the brass ones that you have to remove to see the float level, and we can actually see it in here visually as the car's running. You can actually see the fuel level in there to adjust the float levels with the needle and seat adjusters right here. It's kind of a cool little thing. You can buy those. Several companies make them. Here's one right here by Moroso. It's just a little kit. They're a few bucks. You unscrew the other ones, put the O-ring on, and screw them in by hand. You're basically done. That's a nice little feature. As you notice on this one, the choke has been removed. Like I said, on a lot of the Hollies that we do, first thing we do is remove the choke. We've removed all the choke linkages, so it's just in the way, and it's just, we don't have that hassle of anything in the way anymore. One little thing, though, when we get into rebuilding this, I might as well tell you right now, though, when you take the choke linkage off, there is a screw right here that helps hold the choke linkage on. It's right here, right underneath the secondary diaphragm mounting screw. There's one underneath here. That is an open port. If you take the choke linkage off, you need to put a screw back in there with a little bit of sealer on it. That is an open vacuum port. So if you remove your choke linkage and you don't plug this one back off with one of the existing screws, you will have a vacuum leak. Okay, so make sure you plug that little guy off right there. It's pretty much consistent on all the Holley carburetors. Before we get started on disassembling this thing, let me show you a couple of cool tools that come in handy when you're rebuilding a carburetor. One thing is this carburetor mounting plate right here. It's kind of neat. You can get these from different companies. What's nice about it is you can put the carburetor on it. It holds it up. It's like a pedestal. What it allows you to do is when it's up on this little guy, is we can activate the linkages freely, and it doesn't rock around on the tabletop or anything like that. So we can make sure that linkages are working free, everything's doing, because it's hard on a tabletop sometimes. Or if you have it set up on a piece of wood, every time the throttle plate's open down here, they'll rub on the bottom of the table and the carburetor's flopping around, and it's just not really handy. But this is a nice handy little tool. It holds it up and works real good. Another thing is with this tool is we can flip it over. We can take the carburetor when we're working on it upside down, we can mount it in there, and I can work on the bottom of the carburetor, and it holds it so it's not flopping around like a fish out of water on your tabletop. It's kind of a handy little tool to have. We have a couple of those here that we use every time we rebuild a carburetor. Might be handy for you to get one. They're not that expensive. I'll put this back on here. Other little cool tools, these nice little billet tools. These are Barry Grant, made by Barry Grant company, the company that makes the Demon carburetors. They're real nice, billet aluminum. There's several companies that make these. We have some with the hex heads on them like this. Some float bowl mounting screws are hex head, and that's what this little one's for. This one right here is for main jets, for installing and removing main jets. And this is the correct screwdriver size. It's a machine screwdriver size specifically for float bowl screws. Really nice little handy tool to have. Another handy little tool is this little guy right here. What it is basically is a float bowl adjusting tool. When you're adjusting float levels, these are the needle and seats right here. There's a needle and seat in there, and that regulates the amount of fuel that's coming up into the float bowl. We can adjust that real simply by just taking a screwdriver. You loosen the top. You can adjust this little nut under here. When you screw down on it, when you turn it clockwise, that pushes down on the float, which lowers the float level. So if we screw it down and go clockwise with it, it'll push the float level down. And of course, we tighten it up and that seals it. If we want to raise the float level, we go counterclockwise with it, just like if you're unscrewing a bolt. You go counterclockwise, lefty loosey, righty tighty. Well, we're going lefty loosey with this thing, and that'll raise the float level. Sometimes this is cumbersome and kind of a pain in the butt. So we have a cool tool right here, and it's got O-rings inside of it. You can see a hex right there and a screwdriver inside, and it moves freely. It's two separate pieces. So we can simply drop this on here. That dropped it onto the hex. We can drop this into the screw on top, the retaining screw, and when it's tightened up, we can loosen it. I can turn this and adjust the float level right where I want it, and then crank it back down and tighten it, and done. Nice simple little tool. It also prevents it from leaking, because when you have fuel pressure coming in here, fuel tends to spew around. This prevents it from doing that because it's got O-rings inside of it. So before we get started on a carburetor, we need to get the proper carburetor kits. What I recommend is when you're doing a Holley carburetor, get a Holley carburetor kit. When you're doing an Edelbrock carburetor, get your Edelbrock carburetor kits. Here's a couple right here. Here's an Edelbrock carburetor kit right here. They're clearly marked on the end right there with a part number. You can check in the catalogs or have your local part supplier guy help you pick out the right one. But these have the correct parts for the correct carburetors. So the Edelbrock one's a good one for the Edelbrock carburetors. Here's two right here for the Holley carburetors. And I'll show you these right here. There's two different types. They look real similar, but they're not. This one right here is for a vacuum secondary carburetor. And this one right here is for a double pumper carburetor. And that's why it has two power valves, and we'll find in here that it also have two accelerator pumps and the correct gaskets and everything for a double pumper carburetor. And this one also, same thing for a vacuum secondary carb. You don't get any extra parts that you don't need. These are good kits, and like I say, the parts are correct. Things like needle and seats are the good high flow ones. Some cheap carburetor kits, the little, the bargain priced ones you get, out of the country, don't use. They're junk. Get the correct ones. The carburetor will work the best you can get it to work with these proper kits. So we're going to start disassembling this carburetor right here. First thing we usually start with is just removing the bowls. That's real easy. There's 4 screws on the end. Take my little tool here, flip these off. There's one screw. I'll flip these off here. There's another one. Sometimes the bottom ones get a little bit sticky because the fuel is always down here, and you get soot and sediment and things like that, and sometimes it'll wick its way into the threads. So sometimes the bottom ones might be a little more difficult to get out than the top ones. That's common. Don't worry about it. Like I say, this isn't staged. This is a real carburetor that from a real client that needs a rebuild. So there's going to be dirt in it and things like that. This is a real deal here. So there's the 4 screws right there, okay? Best thing to do too, when you're taking a carburetor apart, before I do this, if you're doing it at home and you're not familiar with taking a carburetor apart, the best thing you can do is get a terry cloth, get a towel, get an old one. Don't get mom mad, but you took her good towel out of the bathroom. But get an old crappy towel, lay it out on a tabletop where it's nice and clean, and as you take the carburetor apart, take the farthest things like such as these right here and set them outside, okay? And then when you take the bowl off, take that off and set it next to it. So you have the center of the carburetor working your way out. When you put it back together, you start from the closest stuff in and work your way back in. And the reason I say to use terry cloth is sometimes parts, when you drop them, especially small parts, they'll bounce. And sometimes they'll bounce right off your table and roll off. And if you've got a check ball or a little needle or something like that for a needle and seat, it'll roll right off the table. Terry cloth, it'll bounce and kind of stick and stay right there. Kind of a little trick I've learned when I was younger trying to do this stuff. So we have a float bowl right here. This is what's inside. If you've heard me talk about floats and stuff, there is the float right there. This is a plastic one, okay? This is what controls the amount of fuel coming into the carburetor. If I take this right here, I can show you a quick adjustment of how this works. I'm going to loosen this up right here so I can actually show you some adjustments. If I screw it down, the way these work right here, they're real simple. The screw on top simply seals the system. The nut underneath is the adjuster nut. So if we screw this down, it'll push the float level down to a certain point. Now it only comes up so far. If I crank it back, it's raising, and look how high. In fact, it's touching the top of the bowl right there. So that's what adjusts our float level right there. Once we get the proper level via the sight plug right here, we'll see the fuel level inside there. We want it just to the bottom there. Once we find our correct level right there, we can take this nut and cinch the nut down. That way fuel can't leak out. But this is what's inside of a float bowl. This is the area that holds the reserve gasoline for the carburetor. And of course right here is the accelerator pump, and we'll be taking that apart next. That's the diaphragm inside there that gives the squirt of fuel through the squirters up on top right here. And that's what squirts the fuel inside there for that when you're off the idle circuit transition and you open up the throttle plates, a big rush of air goes in. Well, you need to meet that air with fuel. And I said before, it takes a second to a second and a half or so for the main jet circuit to start working, because here's the main jets right down here. These are main jets. So the fuel has to come out of the bowl, siphon through here, go all the way up the metering block right here come out through the boosters in here and then down into the motor. And it takes a certain amount of time for that to happen. So you open throttle like that, nothing but air happens. So it takes a long time for that to work. So the transition between the two is this accelerator pump linkage right here, which pushes on this and gives you that squirt of fuel to meet the air to keep that air-fuel ratio constant. So I've taken a liberty here to take the rear secondary bowl off the back of the carburetor, and I laid the bolts out here. I got the bowl right here. Now, some of you might say, well, God, what if you get them mixed up, or how do you know which one is which? Are there differences or are there not differences? They look fairly similar. This is a vacuum secondary carb. It's a single pumper carburetor. So yes, there are differences. One has an accelerator pump on the bottom, the other doesn't. So if we put this one right here on the front of the carburetor, we're obviously not going to have an accelerator pump because it looks like one goes there, but it's not drilled out. It's cast into it, but it's not drilled and machined out to accept the accelerator pump diaphragm. So this is the primary bowl right here. This is a secondary bowl. So you can't really get those mixed up. There is a little point I want to show out to you right here. We're talking about floats. As you can see right here, the bottom one has a plastic float in it because this float has been replaced. They usually come with a brass float. They're just a hollow brass float that's brazed together, soldered together, just like this one right here. Sometimes they go bad. You get a little pinhole in them and it's no longer a float. It becomes a sink. And carburetors don't work when they have a sink in there. They need a float. Let me show you something though. This is something we run into pretty often with supercharged cars. And I'm talking about superchargers like a Vortec supercharger or a Powerdyne or a Paxton, what we call a centrifugal supercharger. This right here is a ATI D2 Pro charger, and what is happening is the discharge tube right here blows right on through this air bonnet right here, right through the carburetor. It's not like your typical supercharger where it sucks through the bottom of the carburetor. It's actually blowing right through the center of the carburetor. And with that, we run into a problem with carbureted supercharged motors like this, and that's what I'll show you right over here next. So what we end up with on a carburetor like this is the bonnet sits on top and it forces air right down through the center of the carburetor on a centrifugal supercharger like that. What that does, and why I'm talking about this right now, is these are the vent tubes of the float bowls, so which air pressure can go in here and go inside the float bowls. What a common problem is with this when you're running higher levels of boost, say 10 pounds to 15 pounds of boost out of a supercharger, you get imploded floats, and this is what they look like. As you can see, they're pretty flat right inside here. That's not the way they're supposed to look, and that messes up the fuel levels and the fuel metering through the carburetor. We can give this kind of a comparison to a regular one. You can see how much imploded this one is right here. That's from the air pressure from the blower getting inside the float bowls, and it literally, these are soft, they're not that hard, and it just implodes these little guys. Well, that messes everything up, and boy, I tell you, you can go to an extreme lean condition and just blow the heck out of the motor when you do that. So what we end up using on some supercharged motors are either plastic floats, which isn't ideal, that's not the best bet to use. Another one we would use is a nitrile float, and they're a little black, looks like black foam. I'll show you one of those when we get into one of the kits a little bit later. And they're a black foam unimplodable float. They're actually a solid material. They can't implode. For supercharged applications, we'll be doing that. And if you're really interested in that, you can look at our supercharged video series and see how we do that and how we tune and how we build a motor for that. And we get into that on those also. We just covered the floats and the bowls, and we saw that the imploded floats can happen with some supercharged, some centrifugal supercharged motors. We don't need those anymore. So we're setting these out on the outer edges. We're going to take a little screwdriver here and just give this a little help right here, kind of pull this off. This is the jet plate right here. We're going to pull that off, and that came off easy. Boy, let me tell you, sometimes these factory gaskets, these brown gaskets, are notorious for sticking. Usually when you take them off, they shred, and boy, they are just a pain in the butt to scrape off and everything. I'll show you some little tricks on that in a minute. This is a jet plate right here. We have a power valve right there, and that's another circuit of the carburetor. We'll get to that in just a minute here. Of course, right here, this is where the bowl fits onto, and these are the main jets right here. This is what meters the fuel that goes into the motor. We can remove the jets. There's a cool little jet tool right here. You can use a screwdriver. I recommend getting a jet tool. Reason being is sometimes you use a screwdriver, it buggers up the slot here for the screwdriver to fit into, and boy, you can really tear these things up. They're just made out of soft material. But if we look at this real close, there's a pinhole down the middle of there, and that's your typical jet hole size right there. And if we look on the side, there's a number. I don't know if we can get a close-up of that or not, but if you look real close, there is a 72 on there. That's a number 72 jet. That corresponds to the hole inside the middle of the jet. Of course, the smaller the number, the smaller the hole size, the less fuel the carburetor feeds through the motor. So we'll take the other one out. Usually they're the same. You always want the same size jets on the front of the motor, and then you want a different size jet on the rear. Sometimes they're four-way, what they call four-corner square, which means they're jetted all the way around evenly. But on the fronts you want the same size, and on the backs you want the same size. And I don't mean that the front has 72s and the rear would have 72s. I mean if you have 72s in the front, you have a 72 here and a 72 there, not a 68 there and a 74 there, because this meters the right side of the motor, this meters the left side of the motor. So you don't want the right side running richer or leaner than the other. So these are always the same. And on the back side, you might have larger ones because the motor's increasing in RPM. So usually the back, if these are 72s, you might have 74s or 76s in the back, something like that. They're usually a couple of sizes difference, but you never want to have on the same metering block different size jets. It's okay to have different from front to back, but not side to side. So this one also is a number 72 jet. So we'll set those in a safe place so we don't lose those. The next thing we have on here is the power valve itself. These are interesting. You just pull them off. This is an inch wrench right here. It's 1 inch in size. You can use a crescent or something like that. Just got to be careful. These simply unscrew. And what this does, we've talked about transitions before. What a power valve does, it's got its own transition. So what that means is when we give it the throttle here, okay, that opens up the throttle plates, all right, which lets air inside. So as soon as we crack this open, we're off the idle circuit. All right, when we crack this open, that actuates a cam right here which pushes down on the linkage for the accelerator pump. That squirts a little fuel through the squirters up here. Once the throttle is stopped, once we've hit that spot and we've stopped, the accelerator pump's not pumping any fuel anymore. By that time, we're now drawing off the main jets. The accelerator pump only squirts as it's being pushed. So when it's in motion, it's squirting through the squirters. If I push it down and hold it, it's done. It won't squirt anymore. It has to fill back up and then squirt again. So as long as we're driving down a road at part throttle or full throttle or whatever, we're drawing off the main jets, okay? Well, when we go to give it a little bit of gas, we crack the throttle open a little more, we open the area, and we've talked about vacuum before, and you don't get vacuum when throttle plates are open, you get them when they're closed. So when we open the throttle a little more, say we're cruising at 40 miles an hour, we're going down the road at 40, and I want to go past somebody, I want to get in the left lane and pass a little bit, so I increase the throttle. I push on a throttle pedal a little bit more, it opens up. My vacuum signal is going to drop. When it drops, it pulls on this little diaphragm. It lets the diaphragm open, and it lets more fuel come through a circuit in here, what they call the power valve circuit. And what that does is it richens the mixture up just for that little bit that you've opened the throttle to help while the engine's under a load, and that's called the power valve circuit. All right, when selecting a power valve for your engine, you want to look at the little numbers on the side here. Of course, you probably can't see them on this camera right here, but there are little numbers. This one is a 6.5. What that means is this one right here actuates or opens at 6.5 inches of vacuum. They're all numbered in half steps, so there would be an 8.5, a 10.5, a 4.5, and a 2.5, and that all corresponds to the inches of vacuum it takes to open this valve. And what that means is when this valve is in the carburetor, this is the vacuum side right here. There's a little diaphragm right there, okay, and that's what vacuum pulls on inside the carburetor. On this side right here, there's a little needle and seat. It's just a little seat right there, and it lets fuel flow through here and out the little side ports. Okay, well, when you have anything above 6.5 inches of vacuum on this particular valve, it closes that valve. So say your engine's idling at 12 inches of vacuum. Well, that exceeds the 6.5, so it keeps this valve closed. As soon as you crack the throttle open and it drops down below 6.5, it opens the valve and lets an extra shot of enrichment fuel in there to help enrich the mixture for that little transition there of leanness. And just like any car, if you ever have one with a vacuum gauge, when you give it the throttle, the vacuum gauge will drop to 0 when you're on the throttle. So that allows us to open up and help enrich in the fuel mixture under a heavy load. As you hold it there and the car catches up in RPM, the vacuum signal starts coming up. Just like when you're cruising down the freeway, your vacuum signal is like, probably 12 to 14, 15 inches. When you give it a little more throttle, the vacuum will drop. That helps allowing this valve to open. Of course, there's no such thing as one carburetor fitting the same engines. This carburetor can fit a 283 Chevy, or it can fit a 454 Chevy, or a 289 Ford, or a 460 Ford. It's not a matter of what it fits or what it could be good for. It's a matter of what it's jetted for and what it's adjusted for as far as power valves and things like that. The different vacuum signals to different motors, of course, a 289 is metering less air than a 454 would be. So it's, 454 is going to have it's a larger vacuum pump. So it's going to have a different vacuum signal, along with camshafts and things like that. When you have more overlap or a lumpy cam, your idle vacuum goes way down. So we need to adjust this. Again, carburetors have all kinds of circuits in them, and they're trying to maintain a specific air-fuel ratio throughout an entire RPM and load range of the engine. And so there's little different circuits that help with all this stuff. So the power valves are pretty simple in what they do. I'll show you right here. Here's a couple right here in the package from Holley. They usually have a 3-digit first number, but the second digit, like 4 or 5, that means this is a 4.5-inch power valve. It means it opens at 4.5 inches of vacuum. This one right here is an 8.5, meaning it opens at 8.5 inches of vacuum. It's pretty simple how these work. They all work the same. They all look the same. There's only one style that fits all the different types of Holley carburetors and Holley-style carburetors. And selecting a power valve, what you need to do is get a vacuum reading on your motor when it's warmed up and when it's sitting there idling. And when it's sitting there idling on performance motors, of course we're talking performance ones here, we're not talking stock engines. A performance motor with a performance camshaft that has a little lumpy idle and stuff, it's not going to idle at 18 or 20 inches of vacuum like Grandma's grocery getter does. It's going to idle with a performance cam between 10 and 12 inches of vacuum, usually in that range of vacuum. So therefore we need a power valve that's going to be 2 to 3 inches lower than that for it to actuate. Otherwise the thing's on all the time, and you certainly don't want this on when it's idling. Many of you have probably heard that when you backfire through the carburetor, you get a lean pop or you have an ignition problem and you spit through the carburetor. What that does is it blows this diaphragm out and fuel just starts leaking. It shuts the power valve where it can't, shuts it off where it can't work anymore, and it's open. There's no vacuum to suck on the diaphragm anymore, so the valve goes wide open. And that's when you get it where the car won't idle. It spits out fuel out the exhaust. I mean, you burn your eyes. You can light a match and light the air on fire because it idles so rich. And many of you heard, yeah, once you pop through the carburetor, you'll pop a power valve. That used to be common in old Holleys. In all the new Holleys, they have a check ball inside there, so when pressure comes up through the bottom side of the manifold, it shoves this little check ball up and stops the pressure from reaching the power valve. It's called a power valve protector or power valve saver. So we don't really have that problem anymore. Okay, well, we got the front of the carburetor off, and we covered the jet plate and the power valve and the jets and all that. Let's flip around to the back side. And remember, this 3310 happens to have a rear jet plate in it. So we're going to pick this little jet plate off here. Sometimes they need a little coaxing. We're just going to give it a little pry right here. You don't want to pry too hard. You don't want to mess up the surface. What you don't want to do is take a screwdriver and jam it down in here and mess up the machine surface or the flat surface. Don't do that. There's little ports up on top right here. There's a little casting area right here. You can put a screwdriver in and just give it kind of a little pry right there. It doesn't take that much. If you mess this surface up right here, we'll peel this one off right here. If you mess this surface up right here, you're going to have an internal leak, and you're going to have fuel leaking through or vacuum, and the carburetor's never going to run right. So be careful of that surface area. But this is a rear jet plate, and here are the two rear jets in this thing. If you notice what's missing on here, it's a power valve. Most of the time on these types of carburetors, we don't have a rear power valve because we don't have a rear, it's not a double pumper style carb. A lot of double pumpers have rear power valves. When you change over to these rear jet plates and stuff, they don't have these. It's just the rear jets. It's just for convenience of jetting the carburetor easier. So we'll go to this right here. We're going to take our little tool, take this jet out, and we'll see what this thing had in the backs right here. I'm going to look, and of course I can barely read it with my eyes. They are 76s. Okay, so if we compare that to the front jets, which we had also, 72s. So we had 72s in the front, 76s in the back, which is pretty normal. There's usually 3, 4, or 5 steps between the primaries and the secondaries on any given carb. That's not uncommon. We can go back here. We'll take this other jet out. Now, mind you, we've been getting this carburetor apart pretty easy. These factory gaskets, these little brown gaskets right here, of course, these look a little shiny. I'm the one that rebuilt this carburetor a couple years ago, and it's been raced a little bit and run for a couple years constant. And the guy likes to keep it tuned up and gone through every now and then. And the reason these are shiny is I oil these or I spray them with silicone spray, because the factory gaskets, this is what they look like when you get them in the kits, in the earlier style kits or in the cheapy kits. They're these brown gaskets, which are what they come with from the factory and a lot of times in the lesser expensive carburetors, the vacuum secondaries and stuff like that. When you get up into the HP series carbs and the really race carbs, they come with different gaskets. But these are notorious for sticking. And I'm talking about sticking when you pry the bowl off or anything like that. These gaskets, they're notorious for sticking to both sides. It tears right down the middle, and they're a bear to scrape off. There's a remedy for that. Spraying with a little silicone lube or oiling it helps it prevent from sticking. There's even a better remedy for that right now. And these are nitrile gaskets. They're made of, basically they're like rubber, but they're nitrile. They're gas resistant, oil resistant, all that type of stuff. And these are some from Moroso. Holley makes them, of course, too. Several other companies make them. These are the bowl gaskets, and these are the jet plate gaskets. You can reuse them over and over again. They don't stick. And if we notice right here, and go back here, I'll pick up a rebuild kit right here. These come with blue nitrile gaskets. All the new kits have these nice new gaskets in them, and they're a non-stick style gasket, which are nice. I'm glad they're putting these things in there because it was a bear to get those things off before. So it's nice that they've come up with that. Now we're looking at the main body of the carburetor. We can start disconnecting the vacuum secondary dash pot right here. I'll pull that off next.